Hello everyone, Kotongwane, the Native God here. Right, today we'll be looking at a topic called kinematics, right, which is a topic we find under one under module 1 for engineering science N3. Right, module 1 in engineering science N3 is known as motion, power and energy, right? And kinematics is essentially a branch of mechanics where we look at the motion of objects without considering the forces that cause the motion, right? Now, in looking at kinematics, we are going to make use of what we call kinematic equations. Kinematic equations are also known as equations of motion, right? Now, before having to use the equations of motion, we are going to look at how the equations of motion come about, essentially meaning we are going to derive the 4 equations of motion, right? It is important that students are able to derive the equations or know how to derive the equations, because there are questions either in your tests or in the examination that is going to require the understanding of how each of the equations of motion come about, right? Now, equations of motion, right, are formulated using the velocity time graph. Right. Now, the velocity time graph is a motion graph. At this point, you should be familiar with motion graphs. In N1 and N2, we looked at the distance time graph. We also looked at the displacement time graph. In N3, we are interested in particular in the velocity time graph, right? And it is the velocity time graph that we use to derive equations of motion, right? Now let's get right into it. Let's consider this velocity time graph, right? Now on this velocity time graph, on the y-axis or the vertical plane, right? The vertical plane of this velocity time graph represents the velocity in meters per second, and the horizontal plane or x-axis represents the time in seconds, right? Now this particular velocity time graph starts at this point, which I've labeled as u, which stands for initial velocity, and the object we're looking at accelerates up to this point, right, where we have v, and v is our final velocity. So as far as denotations go, v represents final velocity, u represents initial velocity, right? Now let us look at how the equations of motion come about by considering this graph, right? Now on this graph, right, as we've said, you have the initial velocity, right? This here is our initial velocity, and then you have the final velocity, right? Right, let's do this, change this maybe to orange. Right, now I want us to look at how we derive these equations. Okay, I want to draw an arrow here. There we go. Right, so this is at that point. And that's at that point. Right, let's change this maybe to that. Let's duplicate this, have it here as well. Right, nice. Now from 0, right, this is where the graph begins essentially, right, at 0. Right, remember I said u represents initial velocity, v represents final velocity, and the time t is the time it took for the object to move from its initial velocity to its final velocity, right? So that time we're simply going to call t, right? Now from 0 to this point is what is our initial velocity, right? So here essentially you have u, right, and then from u to v, that is where the the object accelerated, right? How do we know that this accelerated, right? Well, for one, if you look at the ends of this straight line graph, right, of this straight line, this end you have the velocity, you have the initial velocity, and at this end you have the final velocity, right? That means the velocity changed, right, along this path, right? If there is a change in velocity, right, a change in velocity means that there is acceleration, be it the object is actually accelerating or it is decelerating. So in this case, because the final velocity is more than the initial velocity, it means the object, right, along this path was accelerating, right? So the velocity along this path is influenced by acceleration, right? That is why from this point to this point, the velocity, right, from here to there is equal to at, right? So from here to here, the velocity is u, right? So from 0 to here, you have your initial velocity. Then from here to the final velocity, right, you have this, right? Or how we calculate the velocity, right, in this range is by using the acceleration multiplied by time, right? And that is how we essentially get our first equation of motion, by looking at the velocity from 0 to the final velocity, right? So that is to say, looking at the first equation will be v, which stands for final velocity. What is the final velocity equal to? Right, so remember the final velocity is at this point, right? So looking at this graph, right, how would you calculate the final velocity? The final velocity is essentially this u, so u plus the velocity here, which we have established, is equal to at. So to get the final velocity, we'd have to add u and at, right? So v, the final velocity, is equal to u plus at, right? And that is how the first equation of motion comes about, right? Simple enough. Now let's look at the second equation, right? So all of the equations, we are essentially going to use the graph to establish, right? We've established the first one. The second one, we are going to establish using the area under the graph. Now for a velocity time graph, the area under the graph represents displacement, right? Again, the area under the graph represents displacement, right? So this here is our graph. The area under the graph will represent that displacement, right? So displacement is denoted as S, right? S stands for displacement. And how do you calculate the displacement here? If you look at in terms of the area under the graph, there's two ways in which you can calculate it, right? The first one we are going to look at is by separating the two sections, right? If you look at section 1, so there's two sections, there's section 1 and there's that second section. If you look at the first section, right, it is a rectangle, right? The first section is a rectangle. The second section is a triangle, right? It's a right-angled triangle, right? So the area under the graph, right, one of the ways in which you can calculate it is by separating the two sections, right, and then calculating the area using those two sections. So using this one first, right, this one is a rectangle. The area of a rectangle is length times breadth, right? Now if you look at the length here, the length of this rectangle is t and the breadth is u. T times u is the same as u times t, right? U times t is the same as just ut, right? So you can say this is ut, right, plus the area of section 2. What is the area of a triangle? Half base times height, right? So plus, we know this is going to be half. Now what is the base equal to, right? Now the base here is this one. The base is equal to 80, right? So this will be 80, right? Remember, the area of a triangle is half base times height. So we have half, the base here is 80, and then the height is essentially t, right? This height is t, right? So it's half, the base is 80, and the height is t, right? Now we have two t's here. T times t is t squared, so this can be expressed as at squared, and that is how this equation of motion comes about, right? Now let's look at the third one. Let's look at the third equation of motion. Right, the third equation of motion is also based on the area under the graph. Remember, I said there's two ways, right, for this particular velocity time graph. There's two ways in which you can express the area under the graph. It's by looking at, first by looking at the two sections. The other one is by looking at the shape, the entire shape that you have under this graph. Here's your graph. The shape that we have under this graph, right, is one of a trapezium, right? Now, this is not a typical trapezium, but a trapezium, or we can use the area of a trapezium if the shape we have has two sides that are parallel to each other, right? So if you look at this side, it is parallel with this one, right? So we must make sure that the two parallel sides, we must make sure that the two sides, or two of the sides, are parallel to each other. That's number one. Number two, that those two sides that are parallel to each other are not equal in height or in length, right? If you look at this side is parallel with this one, but obviously they are not equal, right? From here to there is u, from here to there is v, right? Again, from here to there is u, but from here to there is v, the final velocity, right? So because the shape we are looking at, as much as it is not a typical trapezium, but because the shape we have has two sides that are parallel to each other, and those two sides are not equal, and then we have another side which we can take as the height, right? As long as those conditions are fulfilled, then you can take that shape as a trapezium, right? So using the area of a trapezium, right, the area of a trapezium, as the area of a trapezium typically is equal to a plus b divided by 2 times, not t, times h, right? That is the area of a trapezium, right? Side A and B represents the two sides that are parallel to each other, which in this case would be this side and this side, right? From here to there is u, from here to there is v, right? Divided by 2 times the height, and then we take this side as the height. So from here to there is t. And that is how the other formula of the equation of motion comes about. So we said a plus b, right? You're going to take this as a, take this as b, and then take this as our height, right? So essentially here you have a plus b, a being u plus v, which we can also express as simply v plus u divided by 2. So that is a plus b over 2 times the height, and then the height here, right, the height is equal to t, so times t, right? And that is how this equation of motion comes about, right? So to calculate, if you have to calculate that displacement, right, using using a graph if you've been given one, right? You simply use the area under the graph. And the area under this graph in particular, right, can be calculated in these ways, right? Either by using this or using that, right? Now to get the fourth and final equation of motion, right, this is what we consider. If you look at all of our equations have time. This one is t, this one is t, this one is t. So all of our equations have time, right? So what happens in the event that you're looking at a question where you haven't been given time, right? Right? So we have to formulate, or this equation came about being formulated because we had to come up, or they had to come up with an equation that doesn't necessarily need time, right? So what we do in this case is we take your first equation. So your first equation is v is equal to u plus at, right? Take your first equation, right? And then you can take either one of these equations, right? I'm going to take this one because this one will be much simpler to use, right? Now on this equation, we are going to make t the subject of the formula. After making t the subject of the formula, you would then take that equation and substitute it into this one, replacing t, right? So what I mean is, from your third equation, right, this is your third equation. From this equation, now we are going to make t the subject of the formula, right? To make t the subject of the formula, we need to get rid of this mathematically, right? You don't just get rid of it, but you get rid of it mathematically, right? So getting rid of this mathematically, it means you have to multiply by 2 this side and multiply by 2 that side to get rid of that 2, right? So essentially t will be equal to 2s divided by v plus u, right? So making t the subject of this formula, t will be equal to 2s divided by v plus u, right? Now we are going to take this equation and substitute it here. So we are going to replace t with 2s plus or divided by v plus u, right? So you have v is equal to u plus a, and then instead of t, we are going to replace this t with this one, right? So here you have 2s divided by v plus u, right? Now let us take this and transpose it to that side. So then you will have v minus u is equal to this, right? Right, now let us get rid of the parentheses and see what equation comes about, right? So first, we are going to get rid of this denominator here, v plus u, right? To get rid of v plus u, you multiply with v plus u both sides, and then essentially you will have v plus u times this v minus u times v minus u is equal to, and then this side you will have, remember on this side, once you get rid of this by dividing by multiplying by both sides, sorry, then you will be left with the numerator only, right? A times 2s is essentially equal to 2as, right? Now for maths, if you look at this here is a difference of 2 squares, right? Bearing that in mind, it means here you will essentially be left with v squared minus u squared is equal to 2as, right? If you are not familiar with the difference of 2 squares, all you have to do here is essentially get rid of the parentheses. So you say this times this, which is v squared. Then you say this times this is negative vu. And then you say this times this is positive vu. Then you say this times this is equal to negative u squared. And then the vu minus vu cancel each other out, and this is what you're left with. Right? The easiest way of doing it though is by realizing that this is a difference of two squares. Then simply do that. Right? And that is how the fourth equation comes about. Right? From this, you will now transpose this to that side, and you will be left with v squared is equal to u squared plus 2as. Right? And that is how the fourth equation comes about. Right? Now, if you look at the fourth equation, right, doesn't have t. Right? So now you have the option of an equation that doesn't necessarily need time. Right? You can use this equation to either calculate or to calculate any one of these quantities, right, if you haven't been given time. Right? Now that we've established all the equations of motion, right, it is important to understand how or in which plane the object is moving, how that influences our equations of motion. Right? Now I say that because the object we'll be looking at will either be moving along the horizontal plane or they will be moving along the vertical plane. Right? Objects that move along the vertical plane are objects that will either be projected upwards, so will be thrown to the air, or objects that will be released from a platform that is at the top, right, and released towards the ground. Right? So we'll be looking at objects that are either moving in the horizontal plane or objects that are moving along the vertical plane. Right? Now, to use the equations of motion exactly as they are, right, the objects would have to be moving along the horizontal plane. And so if you're looking at objects moving along the horizontal plane, right, this is how you use your equations of motion. Right? Where v stands for final velocity, u stands for initial velocity, a stands for acceleration, t stands for time, and s stands for displacement. Right? Now let us see how we express the equations of motion when the object is now moving along the vertical plane. So if the object is either thrown to the air, right, or it is free falling, right, from the top going to the ground. Right? So first of all, right, so let's look at how you would express the first equation if the object is now moving along the vertical plane. Right? So v remains v is equal to initial velocity remains u plus, now the acceleration when the object is moving along the vertical plane, right, we don't necessarily use acceleration, but we use gravitational acceleration, which is denoted as d. The t remains the same. Right? So the only thing that changed here is the acceleration. When the object is free falling, for instance, right, because the velocity is influenced by the gravity, right, we use the gravitational acceleration as opposed to just acceleration. Right? Second one is s, which is the displacement. Instead of s, we make use of h, because again, if you can imagine, the object is moving along the vertical plane. So we are going to consider h as our displacement, is equal to ut remains the same plus half, instead of a we have gt squared. Right? And the third one, again, you have h, this remains the same, v plus u divided by 2 times t. And then the fourth one is v squared is equal to u squared plus 2 instead of a, you again have g times h. Right? The structure of the equation of motion remains the same, right? But because of the change in plane, or because of the plane you are looking at, because we can't necessarily consider acceleration along the vertical plane, but instead we consider gravitational acceleration. And then in terms of displacement for the vertical plane, we use height for obvious reasons, right? Those are your equations of motion, and that is how they come about, right? Now we are going to look at a question that essentially proves why it is important that students are able to or understand how to derive the equations of motion, right? It is for cases where you get a question like this one, right? We are going to go through this question so you understand exactly why you need to understand how to derive the equations of motion, right? Now, the question has a graph, right? The vertical plane represents the velocity in meters per second. The horizontal plane represents time in seconds, right? If you look at this graph, it is exactly similar, right? It is similar to the one that we used to derive the equations of motion, right? Now, before we discuss the graph, let us first look at the problem statement for context, right? Problem statement reads as follows. The graph in figure 1, so this one, shows the velocity time relationship of a free falling object from t is equal to 0 to t is equal to 4 seconds, right? It says the object is free falling. So the graph in figure 1 shows the velocity time relationship of a free falling object from 0 to 4 seconds. Now, the free falling object part of this problem statement is essential because it tells you if the object is moving the horizontal plane or if it is moving along the vertical plane, right? An object that is moving along a horizontal plane cannot be falling, but something that is falling would have to be an object that is moving along the vertical plane, right? So that gives you an idea as to which equation of motion to use, whether to consider acceleration or to consider gravitational acceleration, right? So this here essentially gives you context as to if the object is moving along the horizontal plane or the vertical plane, right? And saying that they told us that this is free falling, it essentially means that you're looking at an object moving along the vertical plane, right? Now we go to the graph, right? Going to the graph, we have to establish exactly what it is that we've been given, right? We have to establish exactly what you've been given, right? Looking at the graph, so the graph is 0 here, it's 4 seconds at that point, right? Now, here, right, from 0, right, remember that from 0 to this point is what is our initial velocity. So essentially, here you have u, right, and then from 0 to there is our final velocity. So the final velocity here has been labeled or has been denoted as m, right? So the m essentially represents the final velocity, right? So you have m, and essentially you have the final velocity which has been denoted as m, right? So if v is equal to u plus at in this graph, it essentially means m is equal to u plus at. Remember that from here to there is your initial velocity. Then from here to there, right, this is where the graph accelerates, or this is where the object accelerates. But remember, the object is free falling. So it means instead of at, we actually have gt. Right, so in actual fact, m is equal to u plus gt. Right, now let's look at the questions. Right, they said use the graph to determine. Right, okay, before we get to the questions, from the graph, we know you have your initial velocity. It's equal to 16 meters per second. Right, you have the final velocity, which is equal to m. Right, and because this is free falling, we have g is equal to 9.8 meters per second squared. Right, and then we also have time. Right, the time from 0 to here, or the time it took for the object to accelerate, right, is 4 seconds. So you have 4 seconds. Right, that is all the information we've been given. Now let's look at 1.2.1. Determine the value of m. Right, now at this point, you've already established that v is equal to m, and we know that m is equal to u plus gt. So now you simply say m is equal to u plus gt. Right, this we had already established is equal to, what is the value of u we are given? It's 16 plus g, which is 9.8 times time, which is 4 seconds. Right, now if you punch this in your calculators, right, you are going to get 55.2. m is a velocity, so this is in meters per second. Right, very easy. Right, it becomes very easy as long as you understand what you are doing. Right, then let's look at 1.2.2. Right, determine the displacement of the object after 4 seconds. Right, remember in coming up, or in deriving the equations of motion, right, we said essentially there are two ways in which you can calculate the area under this graph. And we said either you get this or you get that. So if you use either one of these equations, you should get the same thing, right? But we are going to use both just to prove this theory, right? You don't have to use both, you just need to use one, right? But for the purpose of making you guys understand, we are going to use both, right? But now remember, this is moving along the vertical plane, so we are going to make use of these two, right? So we're first going to use this one, right? So h is equal to ut plus half gt squared. Right, we're able to make use of either one of those or both of them because the quantities in the equations we have u, we have t, we have g, so we can use this one. And then the second one, we have v, right? Remember, v here is expressed as m, and we've just calculated m. So if our m is correct, we should get the same h that we're going to get when using this equation of motion, right? And we have u and we have t, right? So substituting, right? Remember, the question is calculate the displacement, or determine the displacement of the object after 4 seconds, right? Remember, we said displacement along the horizontal plane is denoted as s, along the vertical plane is denoted as h. So u is 16. T is 4 seconds plus half into G, which is 9,8. Right, gravitational acceleration for engineering science is 9,8. Make sure you use 9,8. Right, times T, which is 4 squared. Now, if you punch this in your calculators, you are going to get 142,4. This is a displacement. Displacement is expressed, or the units of measurement of displacement is meters. Right? Now let us look at what happens if we use the other equation of motion, which is V plus U divided by 2 times T. Right? Now let's substitute. Substituting here, V, which remember is essentially the M here. So V is 55,2. So this will be 55,2 plus the U, which is 16 divided by 2 times T, which is 4 seconds. Right, now punching this in your calculators, you should get the same answer, 142,4 meters. Right, this is why it is important that you understand how to derive the equations of motion, right? Because of such questions, just in case you get such questions. Right, now for kinematics, or for the motion part of module 1, motion, power and energy for engineering science N3, we are going to be looking at such problems where either you are given the graph and you are asked to determine any quantity based on the graph you've been given, or you are given a problem statement and you are required to use the equations of motion. Right? Hopefully you have learned a thing or two here. Right, stay tuned for more videos on module 1. Right, that will help you in preparing for the exam. Right, stay tuned for more videos. If you haven't subscribed, subscribe to the channel so that you don't miss any other content I'll be posting based on engineering science N3. Right, good luck to you all. Cheers.